Here's the live review of the Unit 4 review for circle segments and volume. This review is going to go through all of the work for each problem and then display the final answer. While working on this review, you were provided the odds. I'm going to provide the work to make sure that if you weren't getting that answer, maybe you can check your work and then, of course, check the evens. The first problem here was part times part, so we must have had a chord. 10 times 21 is 210, and that's 15x. So if I divide by 15, I get x is equal to 14. That's the correct answer here. Number 2, the formula we needed was tangent squared, which means we had a tangent and a secant line. 45 squared is 2025. Remember when we do part times whole, when we find that whole line, we're adding. Whole is segment addition. Okay, so we're adding those two pieces. So we have 729 plus 27x. I'll subtract 729 first. So 1296 is equal to 27x. And I'm going to divide by 27. X is equal to 48. Okay. 3 part times the whole, we must have had 2 secant segments. Again, remember that whole line, you add those 2 segment addition. I also took the time to just combine the constants to save some steps here. So we'll have 90 plus 45x is equal to 110 plus 40x. Then let's move over. So I'm going to subtract 40 to get 5x. I'm going to subtract 90 to get 20. X is equal to 4. That's the odd answer that I provided you. Again, we had another secant, 2 secant lines, part times the whole. So 7 times 14, we have 98 plus 7x is equal to 8x plus 88. So if that's the case there, then I'm going to subtract the 7x to keep my x's positive. I'm going to subtract 88 to get 10. All right, tangent squared. So the equation we used, we must have had a tangent. Look back at that PDF, but those of you who are confused, remember that tangent only touches the outside of the circle and the secant line comes all the way through. So this is the tangent. That's what we're squaring there, tangent squared. So we have 45 squared again, which I think is 2025, yep. Then we have that 27 squared appeared again, so 729. Then we have 27 times 48. The 1296x. So we're going to get 1296 is equal to 1296 x, so x is equal to 1. Oh. All right. Part times the whole. Again, we have 2 secant lines. So again, if you're not looking back at that PDF, you're just looking at your work maybe. Those are 2 secant lines. That's an example of what it might look like. Again, I combined my constants first, just to move things along a little quicker. So we have 36 plus 6x is equal to 5 times 12 is 60. We'll subtract the 36. 6x is equal to 24, so x is equal to 4. Number 5, again, part times whole, we had 2 secant lines then. So this is 4x minus 8 is equal to 3x. So this is, let's see here. That's not going to give me a 5 back, so I'm going to look to see if I copied the problem down wrong. This is number 5. No, number 7. So we have part times the whole line. So, but that's -6, so that is -2. 3 plus the whole line is just x. Oh, I'm not following the rules here. This is why this didn't work out, and I didn't even notice here in number 5. So in number 5, I'm supposed to find CD. Stay with me here. CD is this part. I'm just going to make myself some notes here so I can go back and do what I'm supposed to do. 6, I'm supposed to find TU. TU is this part here. Number 7, I'm supposed to find KL. So when I go to find KL, I am going to get 5. And then 8, I'm finding GT. GT is just the x plus 6 part. Okay, did I do that anywhere else? Yes, okay. 13. I'm going to pause the video really quick so I can edit my outline and then I'll resume. Okay, we're resuming the video back, and when we resume the video back, I'm going to come here back up to question 5. I found x equals 1, but the direction said to find CD. So to find CD, I'm going to substitute it back here into this equation. So that's going to give me 27 plus 48x. I am all over the place. How is that not? Number 5, it says find. Okay, CD is just the 48x part. So if I substitute in a 1, I am going to get 48 for CD, which was on my answer key. Okay, let's keep up here. TU is the 6 plus x part. So TU should be 10. Alright, here's where I found my mistake in not copying all the directions down on my paper copy here. I'm going to subtract 4x, so that's negative x. Negative 8 is equal to negative x, so x equals 8. Well, if I substitute that back in here, 8 minus 3 is in fact 5, which is the final answer there for 7. Okay, keeping it moving. Part times part, so we had a chord. So this is going to be 14x. This is going to be 8x plus 48. I'm going to subtract 8 to get 6x equals 48, and x equals 8. Well, x equals 8, but we're supposed to find GT. GT, I underline here, is that x plus 6. So 8 plus 6 is 14. Alright, let's move it along. Question number 9, we have part, or tangent squared, and part times the whole. So this is going to be 36. That's going to equal x squared plus 5x. Now, we've entered into the fun part of this unit, where we can have quadratics. We can't solve a quadratic equation unless it's equal to 0. So I'm going to subtract that 36 over. Remember, I'm looking for something that multiplies to be 36, but could add up to be 5. So I know that's going to be x plus 9 times x minus 4. 9 minus 4 is 5. 9 times a negative 4 is a negative 36. Remember, those are factors. We're looking for solutions. So this is going to be x equals negative 9 and x equals 4. Remember, we choose x equals 4 because we can't have any negative side lengths, so we're not going to choose negative numbers, okay, if it in fact makes a negative side length. The next one in 10, we had part times the whole, so this is 40 is equal to x squared plus 6x. Again, a quadratic, so I'm going to set it equal to 0 by subtracting that 40 to the other side. I'm thinking what multiplies but could add, and that's going to be x plus 10 times x minus 4. And so again, those are factors. But we need the solutions, and we always solve, so that's negative 10 equals 4. And in this case, it's going to be 4 again, so I can have positive side lengths. Part times part means number 11 was a chord. So I'm going to have 2x squared, I'm going to distribute, minus 2x is equal to 9 times 16, 144. So this is going to be 2x squared minus 2x minus 144 is equal to 0. If you'll notice, 2, and 144 all have something in common. When this a value is greater than 1, we want to look for a GCF. That GCF is 2. So this is going to be x squared minus x minus 72. And I'm back to factoring. I want to know what multiplies but could add. So this is going to be x minus 9 times x plus 8. Your GCF isn't a solution. And I'm going to choose 9 because 9 gives me those positive side length vibes. All right. Number 12, part times the whole, we must have 2 secants. So this is going to be 24 equals 2x squared minus 2x. Another quadratic, so we set it equal to 0. Again, we have a GCF. That GCF is 2. So this is going to be x squared minus x minus 12. My GCF isn't a solution, but it's part of my factors. So this is going to be x minus 4 times x plus 3. Okay, again, those are factors. My solutions are x equals 4 and x equals a negative 3. Again, we want to pick some positive side length options. Part times part. This is going to be 42x squared is equal to 14 times 27, 378. Okay, in this instance, we have a quadratic, we have an x squared, but we don't have a quadratic equation. We have a square root equation. So I'm going to divide by 42 to get this x squared by itself, and that gives me 9. So now I can square root both sides. And again, I want positive side length, so that's going to give me a 3. And in this instance, I want TM. I underline TM to be 7x. Well, 7 times 3 is 21. Okay. So TM is equal to 21. The next circle problem here, we have 144 is equal to, it's going to be x squared plus 15x plus 5x plus 15 times 5. So 144 is equal to x squared plus 20x plus 75. Okay, and I'm at the time limit for this first video here, so I'm going to pause and publish. Tune into the second video to finish this problem and to check your answers on volume.